Now we're going to be looking at naming compounds that are ternary. So you should already be able to do the simple ones. We're going to do ones with 3 and more elements. The question of the video is common names of household chemicals vary from country to country and even in state to state sometimes. Chemists need a universal way to name chemicals in order to communicate effectively of what they need to order from what country. What are the chemical names of these common household chemicals? So we have baking powder versus soda, bleach, laughing gas, sand, chalk, and milk and magnesia, and these are just a few of the ones I thought off the top of my head. So ternary compounds are when you have 3 elements or more, and they usually contain a polyatomic ion, which I've given you a list to memorize. So all you have to do is look up the first element's name, which you should know, like silver, and then you are supposed to memorize the polyatomic ions. So these are just a list of a few random examples. You can see they all have 3 or more elements, and they have different endings for the most part, either ites or ates, and then sometimes, unfortunately, "ide," because that was supposed to represent 2 elements when it ends in "ide." An exception that was sodium hydroxide. So hydroxide ending in IDE actually is OH minus. So tricks for memorization, I recommend memorizing the ates, so things like nitrate, chlorate, phosphate, and their charge. So how many O's do they have and what's their charge? Any similar polyatomic with one more oxygen is called a per-ate. So for example, if chlorate is ClO3, then perchlorate is ClO4. Any similar one with ite would be one less oxygen. So if ClO3 was 8, chlorate, ClO2 would be chlorite. And a similar polyatomic that has 2 less oxygens is hypochlorite, right? So that would be ClO. So here you can see these ates are the ones that come up the most often. You need to randomly memorize how many O's and their charges. Some students like to group them and they memorize all the ones that have the same number of O's and their charge, and then all the ones that have the different number of O's and their charge. Other people group them by charge and say these are all the -1 charges, and then they memorize them, and these are all the -2 charges and memorize those. Note that the bi means there's an extra hydrogen, a plus, added to your polyatomic. So if you look at carbonate, it was CO3 minus 2. Bicarbonate is H, CO3 just minus, right? So that will save you from memorizing them. So again, sulfate is SO4 minus 2. Bisulfate is H, SO4 and just minus. So let's play the game. If perchlorate means that it has the most amount of O's, that means it's going to be ClO4 negative. And if IO4, again, also has the most amount of O's it can hold, 4 is usually our cap, this is going to be per iodate. So there's some per examples. So per means you're going to have the most maxed out amount of O's, keeping the same charge that you would have had at the 8s. What are these ones? So chlorite would be 1 less O than your normal chlorate. So this is ClO2 minus. SO3 minus 2 is sulfite, because sulfate would have been SO4. Nitrite is NO2 minus, because NO3 minus would have been nitrate. And PO3 minus 3 is phosphite, because PO4 minus 3 would have been phosphate. So remember, ite means subtracts an O and keeps the same charge. And then what are these? Hypochlorite means it has the least amount of O's but still has an O. So ClO minus, and BrO minus would be named similarly as hypobromite. So remember, hypo means you subtract 2 O's as the least amount of O's of the group, but still has at least one. If we name these all together now, you're going to name the first element and then the ending. So potassium, sulfate. Cesium, nitrite, because it has 1 less O than normal. Strontium, chlorate. Aluminum, bicarbonate, because of that H. And rubidium, acetate. Some covalent compounds are sometimes named differently than what we did in the previous video. You can use the stock system that we used previously, but a lot of people tend to try to use these prefixes to denote how many of each element there are, and this can actually be an easier way of naming. But again, this is only for covalent compounds that only have nonmetals. If it's nonmetal, you can use this system of naming. So you might want to take a moment to write down this yellow writing that tells you how many and what the prefix is, and we can use that to name some of these. So instead of calling this nitrogen nitrogen 2 oxide, no, nitrogen 4 oxide rather, from the last video, you could call it nitrogen monoxide because there's one of each. Notice we don't start with a mon in the prefix of the first element, only in the second element, which is a very strange rule. In the next one, household, we call it water. Based on the last video, you called it hydrogen oxide. In this video, you could call it dihydrogen monoxide. So you do need a prefix if it's anything other than mono in that first element. We could have called this phosphorus 5 chloride, but other people call it phosphorus pentachloride. And last, we could have called this one chlorine 7 oxide, but some people just call it dichlorine heptoxide because it doesn't require you to figure out the charges. Also, again, notice all those were nonmetals, so the only reason why you can use this method. I think it's even easier going the other way around. There's 1 carbon and 4, that's what tetra means, chlorides. Make sure you put that tetra after the chlorine, otherwise it doesn't look like there's 4 carbons. Phosphorus tribromide would be 1 phosphorus and 3 bromines. Silicon dioxide would be 1 silicon and 2 oxygen. So notice that prefix goes after the element. Note that there are diatomic elements that are more reactive than nonmetals, and they react with themselves. So they form 2 atoms bonded together. I think of them as Siamese twins. But if they are going to react with something like oxygen, they'll break apart and go react individually. But while they're alone, it's doubled up. So I remember them as Brinkelhoff. Some people make a 7 on the periodic table and color them in. But you need to know those 7 come together. So last, back to the question of the video, what are these names? I'm going to call that one first baking soda, sodium carbonate. And in baking soda, I'm going to call it sodium bicarbonate. There's a big difference in the two. One has 2 sodiums and one has a sodium and a hydrogen. That actually makes it so baking powder is pretty straightforward, and baking soda actually bubbles when you add water to it because of the formation of H2CO3, which immediately breaks down into water and CO2, which we saw in a previous video. Bleach is also known as sodium hypochlorite. Laughing gas is known as either nitrogen 1 oxide or dinitrogen monoxide. Sand or silica is also known as silicon dioxide or silicon 4 oxide. Chalk is known as calcium carbonate, kind of like sodium carbonate. And milk and magnesia, and remember, watch out for that hydroxide OH. It's one of the only polyatomics that ends in "ide," like most other 2-element compounds. So this is magnesium hydroxide. At this point, you should be able to name all ternary compounds.